Hey everyone, it's Mr. Gilsdorf. This is my first standing video. For honors chemistry, we're going to be discussing dimensional analysis. So in dimensional analysis, what that basically is a way to do unit conversions where you keep track of all of the units as you cancel them out, and you keep track of all the values, and you use known pieces of information to get to an unknown piece of information, okay? So in dimensional analysis, you essentially kind of start with what you are given, and you use the T-chart / train tracks / whatever you want to call it. And what essentially happens is, so let's say we have a number with a given unit, okay? And so we then carry that unit down, given unit, and then we use that given unit to compare to something else that we might know. So then we could say, oh, okay, so then new unit, and then we would carry down that new unit to unit of answer, or whatever, okay? So what we essentially are doing here is making sure that we're using given scenarios, so each of these would be a conversion factor, a given or known conversion factor. And so you put that in, and so you track it with the unit that you start with, and essentially what we're trying to do is get every unit to be in the numerator and in the denominator at some point, so that once we multiply and divide all the numbers, we can cancel out the units that appear in the numerator and the denominator until we're left just with the unit we wanted for our final answer. So let's actually just work through one, because I find a lot of times with dimensional analysis, the more that I just stand here and talk about it, the harder it is. So let's actually just run through a problem, okay? So let's say we're trying to figure out how many minutes are in 4 days, okay? Now obviously this isn't a conversion we're gonna do frequently in chemistry because we don't deal with time as a unit of measurement other than timing things, but this is essentially what we're trying to start with. Is let's start with something that we can familiarize ourselves with, something that we can understand the conversion factors for, so that we can start moving into the things we don't, all right? So we're gonna start with our given value. So this is what we were given. So we're gonna start with 4 days, okay? Oh, that's big enough. Okay, yeah, I was trying to make sure it was big enough. It's big enough. So we start with 4 days, and we're gonna set up our train tracks. And immediately we carry days down here. Now, before we even start worrying about numbers, remember I called this a unit conversion, which means the units are the most important things, and that's what we need to start with. So the units, we want to work through and say, can I build a pathway from days to minutes using units? Okay, units only. Can I build myself a pathway through the units? And I can. So days, I don't know how many minutes are in a day. I'm sure there is a standard value, but I don't know it. But I do know how many hours are in a day, okay? Hours is not where I want my final answer, so I'm gonna need to convert out of hours at some point to minutes, because I know a relationship that exists. So I don't know a relationship that exists directly between days and minutes, but I can use a relationship in between to help me get there, okay? So that's kind of why it's a multi-step process in a lot of cases, because you're just trying essentially to get from A to B, but you gotta pass through a couple things to get there, okay? So notice that you saw, as I just said, the unit here went down here, then the unit that I can convert to goes there, and then I'm gonna put it down there to get here. Now, of course, at the end, that means days are gonna cancel out, hours are gonna cancel out, and we'll be left with minutes, okay? So that's kind of the goal here. Now, you'll notice I didn't put any numbers in because I didn't need to. The important part right now was getting those units in the right place. Now that my units are set up, I'm ready to plug in my numbers and go, okay? So I'm gonna ignore everything, okay? Because I said this was a conversion factor, which means it needs to be a fact. Conversion factors need to be facts. They need to be true. So days to hours. The only relationship I know that exists there is that for every 1 day, there are 24 hours, okay? For every 1 day, there's 24 hours. And then over here, hours and minutes, well, again, I don't know how many minutes are in 4 days, but I know how many minutes are in an hour. And if I know how many hours are in a day, then I can get to the point where I realize how many minutes are in 4 days. So I know that there's 60 minutes for every 1 hour. I'm gonna grammatically fix the day. 24 hours in a day, 60 minutes in an hour. So at this point now, I've worked my way through the units to get to where I want, and I've worked my way through the correct factual values for each of these conversion factors to get to where I want, okay? So now I'm ready to calculate. So let me grab my calculator. I'm back. Okay. So what we're gonna do is, as you move across the top, you multiply, and then you hit enter, and then divide by this, hit enter, and then divide by this. Now I know you're like, they're ones. Why do I have to do that? They're not always going to be ones. So that's the point. We want to make sure that we're practicing it correctly, because we're going to start to get to the point where these values on the bottom are not ones, and in fact could be scientific notation values. In fact, they will. So we want to make sure that we're ready to go with the easier ones to get there. So, okay, 4 days, and for every 1 day is 24 hours, and for every 1 hour is 60 minutes. Now, you could do that as 3 separate calculations, and you probably would have. If I just said, surprise, here's a quiz, and I need to know how many minutes are in 4 days. You would have done both of these conversions in your head, with the calculator, and you would have gotten there, and it would have been fine. But the point being, this allows you to keep track of the units, make sure you're canceling out the units at the right time, and keep track of the values that go with those units. It also allows you to start doing things that you're not familiar with. Because like I said days to minutes. So you're like, well, obviously there's 24 hours in a day and there's 60 minutes in an hour. Yeah, but when you're starting to convert between liters of gas in a mole and formula units and particles and molecules using Avogadro's number, which is 6.02 times 10 to the 23rd, it gets more complicated. So we want to practice this dimensional analysis, and we want to use this because, again, this is one of those skills that I told you about, pre-APIB skills, that goes beyond our class. This is something we're going to use beyond now. So let's go ahead and run this calculation. So I'm going to do 4 times 24 times 60, enter, and I have a value of 5,760. Then I'm going to divide by 1, enter, divide by 1, enter. And I get a value of, like I said, 5,760 minutes. But wait, am I forgetting something? Sig figs. So what we want to do at that point is then go back, check the numbers we had in the problem, as we did today, and check to see how many significant figures we want. We can't have an answer that's more accurate than the numbers we were working with. Now, this is going to upset some of you because you're going to be like, wait a minute, you're rounding how many minutes are in 4 days, but don't we know exactly how many minutes are in 4 days? Yeah, but do we know it was exactly 4 days? Remember? Could have been 4.1, 4.9, it could have been almost 5 days. We don't have that kind of precision without having more significant figures. So what we're gonna do is look at the number here. There was no number here, so this is the number we're working with, 1 sig fig. So then I'm gonna go to 5,760. Hold on, let me write this in black because I realize the red doesn't show up extremely well with the glare. 5,760 minutes. I don't know if y'all can see that, but I put M-I-M. Yeah, that's an N. So with one significant digit, I am going to be rounding to this digit. So I'm going to round to the nearest thousand. 5,760 is definitely a lot closer to 6,000 than it is 5,000. So when I round this, I know it's weird, go with it. I'm saying that in as accurate terms as I could work with, given what I was given at the beginning of the problem, it is approximately 6,000 minutes. Okay, so based on the calculation, it is approximately 6,000 minutes in. It is approximately 6,000 minutes in 4 days. Now, precisely, we know that it's 5,760, but like I said, we know that there was 4 days, but without any more detail, we can't confirm if that was 4.02 days, 4.2 days, 4.5 days, 4.97 days. We can't confirm because we don't have enough information other than just knowing that it was 4 days, okay? So let's go to our paper and look at page 4, all right? And there's some other ones up here. So at the top of the paper, you can see that there are a couple others if you want to look at, but let's go ahead and just do one of them together. So I'm gonna erase this and try to do one that's not so messy since I'm actually, doing this on camera, but whatever. Okay, so we were meant to do the odds. The first one is another relationship that exists between, yeah, hopefully you're definitely watching this video because I'm going to ask you to cross out something. So number 1 is 3 hours to seconds. So it's asking similarly, how many seconds are there in 3 hours? Okay. So again, we start with what we're given out front. So we're going to say 3 hours, set up our train tracks. I'm not sure how many steps I'm going to need yet, but I'm just trying to get it ready. I can always erase. We do it in pencil, obviously, or dry erase. So I know that this unit needs to go down here. Now, why am I not carrying the number? Think about that for a second. Why would I not carry the 3? Because that's the point of a dimensional analysis conversion. The point is, I don't know how many minutes or seconds are in 3 hours, but I can use the base of 1 hour to figure that out. So again, I don't know how many seconds are in an hour. I do, but I'm pretending like I don't, okay? I don't know how many seconds are in an hour, but I do know how many minutes are in an hour, and minutes isn't my final answer, so I know I need to get rid of minutes, and at that point, I know the relationship between minutes and seconds. So again, I carried down the hours so that I can cancel it out. I went to minutes, and then I can carry that down so I can cancel it out, and I go to seconds. Now we want to treat these, remember, as facts. I need to make sure that it is a factual statement. I need to make sure it's true. So 1 hour is how many minutes? Yes, thank you. 60. I'm bored. So 1 hour is 60 minutes. And so, like I said, I don't necessarily know how many minutes are in 3 hours, but I do know that there's 60 minutes in 1 hour. And I don't know how many seconds are in 3 hours, but I do know that there's 60 seconds in 1 minute. I do know that. That's a fact. So I'm going with what I know and using what I know to figure out what I don't know. That's the whole point of a dimensional analysis problem. So again, I have it set up, so I'm going to calculate, in theory, there's my calculator, 3 times 60 times 60, because moving across the top, you are multiplying as you move across the top, and then you're going to divide for each denominator separately, okay? Please practice dividing separately. I know they're just ones, but at least, I know that you don't have to divide by 1, but at least in your head say 3 times 60 divided by 1, enter, divided by 1, enter, okay? So 3 times 60 divided by 1, enter, divided by 1, enter. I get 10,800. So 10,800 seconds. Sig figs. Go back to my problem. 3. That's 1 sig fig. These numbers are awful. They're awful. So 1 sig fig. So that means I need to round this to the nearest 10,000. The nearest 10,000. So I'm trying to decide, am I going to round this to 0 or 20,000? Well, the number behind it says I'm not rounding it. So this would round to approximately 10,000 seconds in 3 hours. Okay. Now I'll do one more. So if you feel like you've got it, you can go ahead and just end the video now, start practicing. Again, you're only doing the odds. Please, I would say if you want to do number 3, it's very easy to figure out how many pounds are in kilograms. I believe it's 2.2 kilograms in a pound. So you can use that if you want to use that. If you want to skip number 3, that's fine. The rest of them you can do 5, 7, 9, and 11. Now, point of information, for 7, we are skipping 6, but 7 is involving molecules and moles, and you might be like, wait a minute, I don't know that. But in 6, there's the relationship. 1 mole is 6.02 times 10 to the 23rd molecules, okay? So that's the relationship. It's just for both of those numbers, and you'll actually use it for several others. And then you see there's some more relationships. Again, you'll probably end up using in number 9, it's liters and moles. In number 8, there's the relationship. A mole is 22.4 liters, okay? So make sure you're just looking around the paper if it's not directly in the problem, because we are doing the odds and we're trying to keep it simple and not do too much. You may just have to hunt around the page a little bit for the conversion factors. But those things in parentheses, those are your conversion factors. So you'll use those just like anything else. You would put 1 mole to 22.4 liters and go from there, or you would put 6.02 times 10 to the 23rd molecules is 1 mole, and then 1 mole is 22.4 liters, whatever you want to do, okay? So I'm going to do one more, and I'm going to do one of those. I'm actually going to do number 6. So if you want to keep watching, you can watch number 6. If you don't, you can end it now and go ahead and do your odds. On page 4, when you get to page 5, you're going to be doing the same thing, but using these conversion factors, okay? Metric conversion factors. All right, so let me erase this so we can do number 6. Again, if you feel like you're good, go ahead and end the video now and get started on your homework. Okay, so I'm going to do number 6. In number 6, it says 3 moles is how many molecules? So 3, let's get rid of this. This is just distracting me. It's distracting me. All right, 3 moles equals how many molecules? So remember when I told you guys we started doing the measurement chart on that first day, and I told you that there's a relationship that exists between grams and moles. And I said, well, if I asked you how many Sharpies were in the Sharpie container, you would count them. But if I ask you how many molecules are in a gram of salt, there's too many to count. You can't count them. And that's why, because a mole of salt would be 6.02 times 10 to the 23rd molecules. That's a lot. So that's the conversion factor. That's one of the conversion factors for chemical quantity that we're going to be working with. So 3 moles to molecules. So I'm going to start with 3 moles. Okay. I know that I need to get rid of that unit, so I'm going to pull that unit down here. I'm not taking the number, just the unit, because I'm trying to get rid of the unit, not the number. Moles. Okay? And again, I then need some sort of factual statement to get to ultimately molecules. Well, it just so happens that on our paper, there is a direct relationship between moles and molecules. And that is that 1 mole of any substance is 6.02 times 10 to the 23rd molecules of that substance. So there is molecules. There is a direct conversion. There is a factual conversion that exists between moles and molecules. So I can do it in one step. I don't have to do anything beyond this. The relationship that exists is what is on that paper. 1 mole is 6.02 times 10 to the 23rd molecules. Kind of ugly because I had to squeeze it in there, but more than likely you'll have to do something similar as well when you're running these and you run across something like that you didn't expect and you don't feel like erasing. And so again, now we say, okay, so moles are going to cancel when I run this calculation. Molecules is what I'm going to be left with, which is good because I want molecules in my answer. That's what it's asking. It's asking how many molecules there are. So I'm going to do this just like I did the other problems. Multiply across the top enter, divide by the bottom, enter, okay? And then that is going to be my final answer. So I'm going to take 3 times. Now, so many students make this mistake where they either don't understand how to do scientific notation in your calculator, and I get it because a lot of calculators are different, or they're just not careful about understanding order of operations. Your calculator is stupid, okay? It's really good at computations. It's not good at thinking. So the problem there is that if you don't tell it that something is scientific notation, it doesn't know and it thinks it's a function. So it's just thinking you're trying to multiply times 10 to the 23rd when in fact you need that number separate to multiply by 3. So what I would recommend is starting with 3 times and then open a set of parentheses, put in 6.02 times 10 caret 23. So that's what it's going to look like on my calculator. Yours might look different, but I put in 6.02 caret 23, okay? And then I'm going to close the parentheses and hit enter. Then I'll divide by 1 and hit enter. Okay, so let's look at the answer we got here. 1.806 times 10 to the 24th. Notice that there is something over there. It also could show up on your calculator as 1.806 E24, okay? That is not the right answer. And especially if you're doing a quiz or something on Canvas and you put in this, it's not gonna count it correct because it's looking for this, 1.806 times 10 to the 24th, okay? So if your calculator is doing this, just recognize that E means times 10 raised to the, that power, okay? So again, our answer is going to come out to be 1.806 times 10 to the 24th molecules, sig figs. Go back to the problem, 3, that has 1 sig fig, so I need to round this to 1 sig fig. I'm going to take the 8, it rounds it up, and that turns it to 2 times 10 to the 24th molecules. And again, you might think, well, that's not very accurate. It's 1.806, it's not 2. Yeah, 3 moles is also not that accurate. So we can't really become more embellished with our final answer than what we started with, okay? All right, so I want you to attempt every one of these. Again, I've told you before and I'll tell you again, it's more important that you attempt it and then you fix it if it's not perfect versus not trying. And that's not just me trying to be inspirational, that's literally how neurons work. Okay, so make sure that you're attempting these problems. Your work at this point is now to finish page 4, odds, and do page 5, odds. Okay, you can do it. Email me if you need help, and I will talk to you on the next class period.